Yes, I'll just get this gyroscope here. And it's just a toy gyroscope, really. But of course, in zero gravity, if you knock it, it's going to tumble, it's going to move around like any object up here does. However, if I get this spinning, just give me a second. So once the gyroscope is spinning, you can just see how stable it becomes. And however I knock it, it's not going to change its plane. It's going to remain in the same plane. I can put it physically into a different plane and tap it again, but it will still hold that same plane, and it's much more stable. So it just gives you an idea of how we use spin stabilization and gyro stabilization for control on board the International Space Station.
Of the magnets. You see, if I can move it on the side, it will again pivot around the axis of the magnet, because it makes sure that the magnetic field inside of it stays the same.
Right. It's astonishing. Can you put it on the track for us?
Yeah. I just levitate it above the track quite high, and I can just rotate it.
So it's actually floating above the surface.
Yeah, it's not floating, it's locked above the surface.
So you could tilt it at an angle and it would still fly around.
Yeah, I can do it like this, and it will just go around like this. I can then go and put it at different height, and then like this.
And lock it at the height.
Lock it, yeah, different height, different configuration.
Right.
And I can even lock it at opposite way. If you could just hold for a minute. High. I'm doing the same thing. I'm locking it upside down, and then it is suspended.
Fantastic. Okay.
Systemprotest.